Hello guys, welcome to Algorithms Made Easy. Today we will be discussing the question swap nodes in pairs. In this question we are given a linked list and we need to swap every two adjacent nodes and return its head. We may not modify the values in the list nodes and only nodes itself may be changed. So we cannot modify the values and we need to update the next pointers of the nodes in order to swap them. So in the first example, as we see that the values are 1, 2, 3, 4 and they have been swapped to 2, 1, 4, 3. So every two nodes need to be swapped. The given constraints are the number of nodes in the list is in the range of 0 to 100 and the node value is between 0 to 100. So let's see what the question is all about. So this is the first example given to us. So we need to swap every two adjacent values and give the result. Now, in order to solve this problem, we will be using a dummy node which will point to the head of the list initially. This dummy node will be called node for the reference purpose. So we need to swap the two adjacent values to this node. In order to swap these values, what needs to be done is, so we'll take those values into a variable, first being first and then a second value and then the second next value, that is the next pointer of the second. When we have these three variables with us and if they are not null, then we will update the first pointer of second.next to first, then we will update the dummy.next to second, and lastly we'll update the first.next to second.next. When we will straighten out this list, we will get a list wherein we have swapped the first pair of nodes. Now we need to swap the second pair, and in order to swap the second pair, we'll move the node to the first position. When we'll move this node to the first position, we need to again do the same logic that we performed earlier, and thus it becomes our recursion or the iterative logic. The next two values to this node needs to be swapped and we'll perform the same logic that we performed earlier and give the result. Now, how about a scenario where we are left with only one node at the end, that is a linked list with odd number of nodes. In this case, the first will be a value 3 and the second will be a null pointer. So now we cannot swap any of the values because we cannot swap null with 3 and hence we will directly return dummy.next as a result. So what we get to know is we always need to check if there are null nodes. Only when the second node is not null, we can perform our logic, otherwise we will not perform the logic. We can do this problem both with recursive and iterative approaches. We'll first see the recursive approach and then we will convert that recursive approach into an iterative approach. So do watch this video till the end. So let's see how we will code this. So as discussed, we need to have a dummy node. So we'll have a dummy node and the next of this dummy will be pointed to the head. Now we'll call a recursive function, we'll call that swap and pass the dummy node into it. As we know, the answer will be in dummy.next, so we'll return that. Now let's see the implementation of this swap method. It will be a void return type and method node. So we took the reference of node dummy as node in this value. If this node is null, then we simply return and this becomes our exit condition. If it is not null, then we first find the first node. So first will be node.next. Now we'll define the second node which will initially be null, and only if the first node is not null, we need to find the second node which will be first.next. Now if only the second is not null, then we need to perform our logic that we discussed. So we'll first need to find the next pointer of the second. We'll hold that into a variable called second next. Now we need to perform the step that we discussed. First updating second.next to first, then updating node.next to second, first.next to second next. Once we are done with swapping the two values, we need to call a method again on the reference variable first, like we discussed in the explanation. So we'll call the swap method again on the variable first. When we run this code, we get the right result. Let's test this for an odd number of nodes. So it is giving right result. Let's submit this. So it got submitted successfully. This approach has a time complexity of O of n, but the space complexity is also O of n, as space is needed in order to maintain the stack in case of recursion. So we need to convert this approach into iterative and make the space complexity O of 1, that is constant space. So we'll convert this same logic into iterative. So we'll first take a node which will be our dummy. In this case, we'll remove this method call. We'll take this whole logic. Now, as we were returning node equals to null return, that is the exit condition. Similarly, now we need to perform our logic till the node is not equals to null, and the whole logic will remain the same. Now, instead of calling the same function again, we need to update the node value with the pointer first, like we discussed. Let's remove this from here or comment it out. Now there is one more condition that we need to add over here is, if the second is not null, that means there are no two values that needs to be swapped, and we need to break our loop over here. So if it is null, if the second is null, that means break this loop and come out of it. Let's run this code. So it is again successful. Let's add even number of values. So let's submit this. So it also got submitted. The space complexity in this case becomes O of 1, while the time complexity will still be O of n. We have also solved many other linked list related problems, so do check them out. Some of them are being provided at the top of this video. Thanks for watching the video. See you in the next one.